Our next presentation is going to tackle the issue of artificial intelligence for the enterprise. So if you could, all right, we've got the podium up here. A couple of questions that's going to be asked is, where are we? Where are we going? And we're going to get answers to those through the view from IBM Research. So if you would, give a warm round of applause for Mr. Moshe Rappoport from IBM.
So, it's almost lunchtime, and you've heard two very good speakers in front of me. I'll try not to repeat too many things that you already heard till now, but I would like to bring out a few things that haven't been touched on today. I'm going to talk about the going from artificial to intelligence. And that's about AI in the enterprise. What do I mean? What I mean is that we have had a lot of work on AI that goes back many, many years in IBM, in many universities, many companies have worked on it. But in a certain sense, it was artificial, which means that there was nobody was really making any money with it. Now, we're coming to a new phase where we're going to take all these technologies which have been created over the last 30, 40 years, and we're going to try to make some intelligence out of it and to get it into the real world. First of all, let me tell you who I am, where I work. So I work in IBM Research. That's the part of IBM that can't sell you anything. We don't have bonus plans. We just try to create new technologies which hopefully our customers can use and IBM will sell. But we do a lot of scientific research. We publish a lot of papers. We create a lot of patents. We win Nobel Prizes and things like that. Actually, the lab that I work in is the main European lab, which is located in Zurich. And we have 4 Nobel Prize winners by us in physics. But we work on a lot of topics which you use every day. But that means we worked on it quite a few years ago, and now it's into the real world. I myself, I'm going to switch to German just for one slide. This is a picture of me when I was a bit younger. Mittlerweile bin ich ein alter Hase. I'm an old rabbit in the meantime. What I mean is that I've been working in the IT field since 1969. Some of you may have been born by then. Most of you maybe not. And I've gone through a lot. I've seen a lot, been there, done that. As a matter of fact, if you look at one of these nice official IBM charts, we're in the third age of computing. The first one, I sort of was born around that, was the tabulating systems era, when we used machines that were basically hardwired to add up numbers. They couldn't do very much more than that. When I got into IT was the middle time that we would call the Programmable Systems Era, where we were able to write programs in languages that probably most of you have never heard of anymore, like COBOL and PL1 and things like that. But we actually got the computers to do sort of what we wanted. Now, the problem with the Programmable Systems Era was that any problem that you wanted to solve, you had to sit down and write a program. And in those days, that wasn't easy. It took a long time. It was very common that when management came, they wanted a new computer program. It took 2 years till they were able to get anything out of it. The third era, and this is the most exciting era, and I'm happy that I still was around to live through it, is what we're starting to call the cognitive or the AI systems era. And for all practical purposes, This started in 2011, and both of the speakers before me mentioned what happened in 2011. The researchers of IBM decided to tackle a very, very difficult problem, to create a computer which could beat the best players of a television quiz game called Jeopardy! Jeopardy! Is different than most quiz games because instead of asking you a question and you've got to look up, got to come back with the answer, it's inverted. They come with the answer and you got to guess what the question was based on the context. And that means you've got to know about a lot of things, and it had never been done before. So we had to solve a lot of problems on the hardware side, on the software side, and actually in 2011, the Watson computer, as it was called, beat the two best players that were on television at that time, and then everything broke loose. Everything went wild, because suddenly people said, hey, you mean you can actually build a computer which is fast enough to think about all kinds of things and can be trained to answer questions in a very convoluted form and still do better than humans? And the answer for the first time was yes. When that happened, and what happened next was that everybody woke up. It was called the end of the AI winter. Until then, AI was sleeping. It was in universities, people were playing around with it in research labs, but nothing really was happening. Suddenly in 2011, the winter was over and the spring came, and the next thing you knew, you were getting statements like AI is going to transform every job, every profession, and every industry. And actually, we believe that. But how was this going to happen? What was going to happen that would change all these industries? And I have to say, we had a lot of ideas in IBM, but we didn't know the answer ourselves. Now, luckily, we had created in IBM Research an organization which allowed clients to come to us and talk to us. It's called the Think Lab. And what happened was that every company you could think of under the sun was rushing to IBM Research in those days, talking to us. So what is this thing? How does it work? And what can we do with it? And on the other hand, our researchers were talking to the clients and saying, so what do you need? What do you want? Where do you see the needs? So we were a bit surprised, and what happened was that the clients, instead of all the cool things that you're seeing here on AI, were asking a completely different set of questions. And actually, these are fair questions. The questions were, first of all, what does AI mean for my company, for my enterprise? And second of all, where am I going to get all the data from, and how am I even going to know if it's reliable? And then they wanted to know, well, how are you going to combine all kinds of data and start to give me AI answers to my questions? And how am I going to manage all of this? Now, that's a key question for companies. You know, when you're doing something cool in the lab, nobody asks how you're going to manage it, and access control and security and all these things. But at the moment when you're starting to run a company and you got the company's future depending on it, you better be able to answer the questions. So we realized that we are coming with this AI into a new era. I call it the follow the data. You remember the police car, the policeman jumps into the car and says, follow that car. Or you remember when they said, you know, we want to figure out who the criminals are, follow the money. Well, the new question was, follow the data. And we had to understand, how do companies collect data? Where do they have it? What do they need? What are they going to do with it? And so on. So you get a roadmap, and we have some fancy words there like ingestion. Ingestion is just a nice way of saying sucking in the data into the AI world. It sounds easy. It's quite difficult, and we actually have a lot of researchers working on that. Curation, another fancy word for saying, what is this data? Does it mean anything? Is it correct? Is it fake news? What's going on over here? Who is in charge of it? Can we rely on it? Then there's collaboration, because in every company there's a lot of different departments, and everybody has different ideas who owns the data and what you're supposed to do with it. And then you start to get the interesting stuff, the analytics, and finally you're looking for some kind of a business value where you can actually change your company, change the way you talk to your customers, and so on. So you've got to follow the data through a company in order and go through all these steps and make sure that they work. But that's not enough. In a company, there are a lot of other questions. What kind of hardware is this going to run on? Where are we going to store this stuff? Is it going to be in the cloud or a hybrid cloud? Is it going to be, what kind of networks do we have to build to run this? And who's going to write the applications? These are not the questions you heard by the first two speakers today, but these are the kind of questions that we were hearing from all the visitors coming to our offices in Zurich and around the world. They are very, very fair questions when you're dealing with enterprises. And governance. Is the data going to be secure? How are we going to manage the access control? Is it legal what we're doing? These are questions that companies ask. Now you should ask me, and you're allowed to ask me, who cares what companies want? Well, I'm old enough to tell you a little story, and that is that when the personal computers started to come out in the early 70s, and there was Commodores and PETs, and there was Tandys, there were all kinds of computers, and it was basically, for playing games. And then in 1981, IBM came out with something which IBM called personal computer, PC. Actually, we came up with that name, I think. And what happened was that at the moment when PCs, personal computers, started to go into companies, that's when the personal computing world exploded. Exactly the same thing is going to happen with AI, because you're going to have all kinds of nice little gadgets on your desktop or or you're going to be wearing and so on that are AI driven, but the real motor to make AI become real for the whole world, that is going to be when the companies accept it. So these questions are very, very fair, and we realized if we only look at the icing on the cake, the last part, we're not going to get anybody to use it. We really got to follow the data through the whole company, who is doing it, and not only that, and we realized something else. We have to put into every one of these points AI technology. In other words, you get AI-driven systems, AI-driven storage, AI-driven privacy, AI-driven security. And then if you do that right, the end result is that you will have AI helping you to change industries and make your company work better. Now, simultaneous to the AI revolution, we had another revolution, which was the explosion of social media. Social media says that when I was growing up, everybody had a Tagesbuch, a diary, where they would write down what they did that day and who they saw and what they did. And in those days, if I looked into your Tagesbuch, I was a bad boy that I looked into your private stuff. Now what flipped was that along came some things like Facebook, which contains exactly the same information, but now if I don't give a like within a few minutes of what you wrote there, I'm a bad boy. The whole world flipped in the idea of what information is. And companies realized that in this new world of data, there's a lot of value also for companies. And we had to figure out how to get this value out. So that meant creating new kinds, using AI to read what's called unstructured data and try to put some structure into it in order that you can combine it with other things. But that's not enough. There's another problem that companies face and that we all face, and that's called lots of data. When did we, in research, in IBM Research, we were asked by the European EU to help them with a project which said, we want to collect data from outer space and see if there's anybody intelligent out there besides us. So they set up in Africa and in Australia all these satellite dishes which collect data coming in from outside. And now, here's the problem. Each one of those satellite dishes sucks in more data per day than the entire internet has traffic on it. Now, the analysis is not taking place in Africa. It's taking place in Amsterdam. So how do you move so much data from Africa to Amsterdam? And the answer is impossible. You can't do it. It just ain't happening. So what you got to do is we had to build into each of these satellite dishes a supercomputer that throws away most of the data, says this is probably not interesting. And this taught us that when you have lots of data, you have to become very, very selective which ones you actually want to do something with. And otherwise, you have a situation that looks like this, where the networks can't handle it, the storage can't handle it, the computers can't handle it. So we get into an area not only of extracting the data, but also deciding what you want to keep. That sounds trivial, but actually we spend a lot of time trying to figure out how to do that. So when we spoke to all these customers that came to our labs, we realized maybe in the beginning we thought, oh, with this new AI, one size fits all. But actually, we realized there are no two companies in the world that are built the same way. They have different organizations, different needs, different sources of data, different ways of working. And therefore, we realized that we have to build some kind of a stack of tools which allow us for each company to look what do they want to do, where they're going to get the data, how are they going to clean it, how are they going to protect it, how are they going to distribute it, how are they going to process it, what is going to be the end result, how is that going to help the company change. And this is what we call, as I mentioned before, AI in the entire stack. Not only do we want to get AI out at the end, but we have to put in AI at every step along the way if we want to do it. So that means creating new kinds of systems. For example, if you look on this pile of salt crystals on the right side, you'll see a little black dot in the middle. Well, if you want to see what that black dot looks under a magnifying glass, you look on the left side. That's actually a supercomputer, which is as small as a grain of salt. We're going to need those kind of computers to suck in data and decide what to keep and how to transform it. On the top end, we just announced this weekend, and you may have heard about it, the so-called Summit supercomputer. We're soon going to find out if it's the fastest in the world, but it's certainly the biggest in the world at the moment. And it was designed from the ground up in order to process AI data, to train systems, to suck in data, to do all the things that we were talking about in the most efficient way possible. Very high throughput between the chips. As a matter of fact, we have Power 9 chips from IBM running the show, and then we have GPUs from NVIDIA, which are much faster at processing the parallel data, so the two are working together for the AI, in the AI space. The thing, of course, that also every company is asking for is data security. It's asking for privacy. And so we're doing a lot of research how this is going to work in an AI era. Then when we had a lot of the pieces together, we had to start taking the Lego pieces and building things. In order to do that, we needed some real live cases. So the first thing that we did, we decided to eat our own cooking. We went to one of the biggest enterprises in the world, which is called IBM, and we decided, can we actually use these new things that we're building to change the way the company works? So we figured out, first of all, how do we help our salespeople do a better job of understanding their clients based on what we know internally in IBM, what's going on in the news, what the weather forecast is tomorrow. All kinds of data get sucked in, and we help our salespeople talk better to our customers. Then we did the same thing for our own internal supply chain. We have tens of thousands of suppliers, many, many products all over the world. We have secondary suppliers. Can we use AI to make our own supply chain much more efficient? The answer in both cases was yes and yes. We can make sales a lot easier, marketing a lot easier with AI. We can make supply chains. And once we knew that we could do it, we started to look at other industries, and the one that's always brought as a good example is also because we need it is health. And here's the reason why. The amount of medical knowledge is exploding to the point that it doubles every 73 days. There is no doctor, no professor in the world that can deal with that data. You need AI to deal with it, to figure out what's going on, what does this patient have, what does he need. And there are many other areas in healthcare where you take the knowledge and you simulate things, you create experiments, and we have become pretty famous also for looking at medical images. You saw before some presentations about image processing. Turns out that medical images is an area where humans are pushed to the limits. The best doctors, there aren't too many of them. They look at hundreds of images per day. There's only so much you can see. The computer helps them see things that they may have not looked at. Then we took it to industrial companies. So we worked with one of the bigger auto manufacturers here in Europe in order to see how would they use AI. And they did it very, very smart. They first made an inventory. What data do we need? What do we need to manufacture? What do we need to talk to the customers? What are we going to do in the car with AI? They collected all the data in a data lake, and they built all these layers that I showed you before in order to actually get a lot of value out of it. So today the situation, 7 years later, after 2011, is that AI is really starting to change industries. I can tell you from my job in the Think Lab in Zurich, we are talking to every industry that you can think of, and their ideas are starting to bubble up. They are really starting to see where the value is. You name the industry, it's probably on this list. Another industry where we're making a lot of progress, for example, is the financial industry. Is a credit card transaction fraudulent? Can we use AI with deep learning to figure this out in real time? We are trying to figure out financial crimes by building knowledge graphs. We are doing for the insurance industry, we're looking, and this was mentioned already earlier today, new ways of assessing risk. And we don't know where it's going to end up, but basically we can do a lot of things with AI that was never possible without these tools. So where is this all going, and what do we have to think about? Well, if we're looking ahead, you probably, if you're in the AI field, you probably know what I'm going to say now. I'm just making it a little bit more understandable. We speak of narrow AI, broad AI, general AI. So narrow AI is what we've been doing for the last years. It's narrow. You define some subset of what you're trying to do. You train the system, and it can do a pretty good job. So I think that the state of the art is, and this is when I was growing up in America 50 years ago, Volkswagen was trying to break into America with the boxy-looking cars. You remember the American cars? They all had fins, and this looked like a box. So they had very funny advertising to catch people's attention. So there was an ad then for the Volkswagen bus. There's a surprise in every box. In narrow AI, I can probably write a program that will go through all the ads, realize this is an ad, this is VW, this is Volkswagen, and it could probably find the text, there's a surprise in every box. I think we can do that. IBM is actually working with an image company to do things like that. That's where we're up to today. What comes next is, why was that ad so funny? And the answer is, if you look at me, the reason is because we grew up with a snack, a very sweet, sugary snack in America called Cracker Jacks, which also came in a box. And there was a surprise toy in every box. So this was a play on that. There is a surprise in every box. They were talking about the car, but they were referring to the candy. This is where we start to talk about broad AI. Could we write an AI program that would say, you know why they made this joke? It's because in America everybody was eating this candy and they were playing on that. That takes a lot more context. That's much harder to do. And sometime in the future, and I'm not putting a date, some people say 2050 or maybe it'll be earlier, the computer should be able to make its own ads. And also, just as funny as anything we can make. I don't know if I'll be around to see that, but that's probably where we're going. But we're going to need more computing power, and that's why we are doing things like quantum computing to try to figure out how to make computers faster and faster and deal with more and more data. Now, the biggest quantum computer that we've built has 50 qubits, 50 quantum bits. Doesn't sound like a lot, a computer with 50 bits in it, right? Except that you remember the story you heard as a child with the king with the checkerboard, 1, 2, 4, 8, 16, 32. Every time you add one more quantum bit to the computer, the computing power doubles. So by 2 to the 50th speed, you can do very heavy computing. And we see this as a basis for the future of AI. Now, we need to think seriously, and it's been mentioned today, where is the new border going to be between man and machine? And we speak about ethical computing, and you heard this before from the other speakers. How are the programs being written? Is there a bias? Is the data clean? And we need human beings, and I'll explain to you why we need human beings. This is something that I experienced when I was, in the early days of the PCs. It was called the VisiCalc effect. VisiCalc was the first spreadsheet. It ran on Commodore PETs. And it pretty much works the same today as an Excel or any other spreadsheet. You have the columns and the rows. And the problem we had then was that as soon as you had a nice computer output like this, the management all got excited. And they said, oh, this number must be correct. But we all know that in a spreadsheet, you only see the results. The formulas are hidden behind behind each cell. So if somebody made a mistake and he said instead of B2 times C2 gives you D2, he made a mistake and he typed B2 times C3, it still would look perfectly fine. We had to train the management in those days, don't believe everything the computer says, because sometimes people make mistakes. Well, here in approximate computing, which is where the era we're coming into, the software is AI. AI doesn't give perfect answers. It gives probabilities for 95%, maybe better than humans, but never like 100%. The hardware is becoming approximate because quantum computers don't work with zeros and one. They work with 0 and 1 and everything in between, and sometimes zeros and ones. It's approximate. So you're going to have very good results out of AI, but you got to take it with a grain of salt. So we have to teach our managements, when you get a result from the computer, think along. Maybe it's right. Maybe it's wrong. Ask. And we're going to need to train people who know how to do this. So to conclude, companies are going to start to adapt AI, and they already started, and we have already quite a few interesting success cases. It helps them discover things that humans can't discover. It helps them learn new things on its own. It helps them engage with customers in ways that we were never able to engage. And it helps us recommend. It's insight and foresight at scale. This is why all these companies are excited about it. So I've come to the end. I could talk much more. I could tell you about cool things we're doing in IBM Research, and they would be very, very fascinating. But I ran out of time. There's already a thing here telling me stop, stop, stop. So I got to stop. But I'll be around today, so if you want to hear more about what we're doing in IBM Research, either on the cool side or on the enterprise side, we'll talk to you. If you want to come to our labs with your company to hear what we can do for you for the future, that's an open invitation. Thank you for listening, and have a great time here at CEBIT.
And that was a great presentation, and we want to let people know if they want to ask you questions or talk with you, you're going to be over in the Ask Me Anything corner, which is just over there.
Okay.
And so they can ask you questions now too.
Okay.
All right, but thank you very much. It's good having you. Thank you. Thank you.